100 times. I'm trying to do my science homework so I won't have to do it when we get to the resort. Shh, we're almost there, Vanessa, and that wasn't nice. Why don't you teach your brother about waves? Mom, do I have to? You should. It would help him understand the rides at the park.
What's that on the top of the sign? Theo asks.
That's a transverse wave, Vanessa answered.
Wow, there's going to be an ocean at the park? I want to go try surfing.
No, silly. There are many different kinds of waves. In class, we learned that a wave is a traveling disturbance that moves through space or matter. It transfers energy from one place to another.
I'm still a little confused, Vanessa.
There are waves all around us every day. Sound is a type of wave that moves through matter and then vibrates in our eardrums so we can hear it. This kind of wave is a compression wave. The wave pushes together and then pulls apart.
Oh yeah, just like my Slinky.
Yeah, that's right, Theo, says Vanessa with a smile.
Wait a minute, Vanessa. Are lights waves too?
Yes. Light travels in transverse waves. They move perpendicular to the direction of the wave, just like fans at a baseball game. As the family drives up to the park, Theo ponders to himself.
I always wondered why they call this place the Electromagnetic Amusement Park. These rides have such funny names.
That's because each ride has something to do with the electromagnetic spectrum. There are different types of light waves: gamma go-kart, radio rocker, infrared Ferris wheel, microwave mixer, and the haunted hospital and x-ray.
I had an x-ray when I broke my ankle, but I didn't see anything, and I definitely have never heard of a gamma ray.
We can only see a small amount of the electromagnetic spectrum.
Aw, man. I wish I could see all the light in the electromagnetic spectrum.
Nah, that would be very confusing. Anyway, the visible light we can see is very beautiful, especially if you see it in a rainbow.
What? A rainbow is visible light?
Yes, the colors of the rainbow make up visible light. When we see the colors of the rainbow, each color bends according to its wavelength. That's called refraction.
Mom, look, there's your favorite roller coaster, shouts Theo. Let's get on.
The kids head to the front while the parents reluctantly find seats in the back.
I wonder what the distance is between us and our parents, wonders Theo.
That's easy, says Vanessa. That's called wavelength.
What in the world is a wavelength, Theo asks.
It's the distance between two similar points on a wave, just like this roller coaster. Our front car and our parents' back car are on the same points of the roller coaster.
Are there any other parts of a wave?
Yes, Theo. Amplitude is the distance from the top part of the wave, where we are now, to its median. That reminds me. Get ready for this drop. Now we're at the trough, the lowest part of the wave. See that microwave mixer? That ride has the longest wavelength and the shortest frequency.
Not to mention it's a kiddie ride, says Theo under his breath.
We're on the gamma go-kart, which has the shortest wavelength and the highest frequency. As the family went to get ice cream, Theo had more questions.
Why do I see lightning before I hear thunder?
You have so many questions, Theo. You see, Lightning, you see lightning first because light travels faster than sound.
Cricket? I'm still a little confused, Vanessa.
Well, light doesn't need a medium, so it can travel through space without bouncing off anything, unlike sound, which needs a medium. At the end of the day, the family had gone on every ride at least twice. Theo was still a little upset about there being no ocean, but he knew a whole lot more about waves. That was really fun, but the haunted hospital and the x-ray was not as scary as I thought it would be, mutters Vanessa as the family piles back into the car.
Oh yeah, thanks for teaching me about waves.
Anytime, Theo.